Good afternoon, everyone. In this video, we'll be discussing about stateful servers and stateless servers. So, for some of the protocols and applications, a server may have to maintain some information which is actually specific to a particular client, or it can even be an information which is specific to all the clients. This is the global information. But let us first look at this information which is specific to that particular client. And during a service session, so during a client is actually being supported by the server, that information may have to be maintained. Say, for example, consider a protocol, something like a file transfer protocol. And if a file is actually transferred in blocks, so that means like this requires several rounds of data exchanges to basically complete the file transfer. Say, for example, like if there is a server, file transfer protocol server, and then like there is a client, and the client is actually requesting this particular file information, the information is actually sent to you in several blocks. That means like there are several rounds of exchange of data happening between the client and the server. So this information has to be maintained. The state information actually has to be maintained during the complete file transfer. So typically a dialogue between a client and a server with the FTP protocol will be something like this one. The client basically asks like, please send me the file in some directory. And the server says okay, and it basically sends you the block 1. Then the client basically says like he got it. Then the server again sends the information, so here is the block 2. And the client again says like it got it. So that message continues until the complete file is actually sent to the client. So this is a typical dialogue. During all this information, the server has to maintain some information specific to that particular client. Which block is actually visited earlier and what is the block which is to be sent next. Some of this sort of information. This is actually called the state information. So typically when you have to support this type of protocol like the FTP, if the server is not stateful, so that means like it is a stateless server, it is the client's responsibility to carry all the information that is necessary for the particular communication. So here is an FTP server and here is an FTP client. So when the client is basically trying to get the file name, which is in particular directory, the FTP server will basically give it the file ID in the first communication. Then in the second communication, basically the client has to tell like send that particular file ID of that particular file, send me the block 1. Then server will basically send here is the data from block 0 of the file. So the client asks for block 0 and then like the server sends you the block 0. Then the client has to actually give all the information and has to ask for block 1. So send file ID and block 1. And then like the server is the one which actually sends like the block 1 of the file. And this message, this communication basically happens between this FTP server and FTP client until complete file is actually downloaded for you. Then it is the FTP client which is actually maintaining the file ID after like it got it from the server. And also like file position, in which block it is, actually it is up to the FTP client. Here is a stateless server. So server is not maintaining that information. But when it is stateful server, the server is the one which is actually saving certain information. So the file ID and the position with respect to that particular client. So a stateful server actually maintains stateful information on each active client. By maintaining such an information, once you maintain such an information, say for example, the communication can be something like this. Get the file name, and the server responds like ready, and then like the client basically asks like send the next block. Then the server sends like block 0 from the file. And again, like the next time like the client asks like send the next block, data from block 1 of the file. And it is the server which is actually maintaining for that particular client, for that particular file, which of the block it is currently sending and what is the next block it should be sending. So all the information is actually maintained here. So that is the stateful server, and then that is the state information it is actually saving. Once you save such information, so this can actually reduce like the amount of data that is actually being exchanged, and thereby like the response time as well. You can actually reduce it. So when you think in terms of whether to use stateful server or like stateless server, so stateless server is a straightforward code. So it is relatively very easy to implement. Okay, whereas a stateful server is very harder to code. However, like once you basically maintain this sort of state information, okay, this can actually reduce like the amount of data that is actually exchanged. Okay, in that sense, like we can actually allow enhancements to the basic service that is actually being provided. Okay, at the same time, maintaining stateful information is very difficult in the presence of failure. What happens, like say for example, the communication has been lost somewhere in the middle, okay, and the data is actually lost. Then the client resubmits the request, the server should know like the previous message has not received. So it has to send the previous block. Okay. So this sort of information has to be maintained by the server. What happens if the server itself has, due to some reason, like got shut down? Okay. Then the next request it gets, so it has to basically somehow remember all the information, save it somewhere. Okay. And then like next time, like when the server is up, when the client request is coming, it has to send that particular block. Say for example, the client is asking for block number 11, it has to give the block number level of the particular file. So the server has to maintain all that information. So the stateful information, it may have to retain somehow. So we have already seen, so basically like we need to maintain certain information, okay, with this particular state, okay. So with the protocol like FTP, there is a need for the server to keep track of this progress of the session. So that's what the examples are we are talking about. What is the sort of information we need to save? It should be like we have already seen, like which block is to be fetched next. That is the information which is to be sent. Okay. So basically, like this is the information it has to save. Okay. A server actually maintains this information, and this is actually called as session state data. And it is per particular session. Say for example, like a client is actually talking with the server, and this is what we have talked about, a session, a single session which actually maintains all the information, and whatever the data that is actually being stored, okay, during that particular session to make it stateful, that is called the session state data. Say for example, for this FTP communication which we have seen, the session state data actually includes the name of the file being transferred, the current block count, okay, so what is the current block which is actually being sent, and it may also have to save other information, something like the action, so whether you are getting the data or the putting the data, okay. So whether saving files or like downloading the files, so which are actually being performed on the file actually. Okay, so it is the same for both the things, and then like the server has to maintain all this state information. And if you think in terms of a complex application, something like a shopping cart application, which is very common for you, which you have been using, okay, so in internet-based applications, okay. So even there, like you have to maintain, the session has to maintain all the state data, and the state data actually keeps track of the client, some identifier for that client, that is a shopper, and also like all the items which he has actually brought already. So the cumulative content of the shopping cart which he has already selected to buy, and this is the one which you will be carrying for when you are basically checking out. Okay, so you will pay for all the things. But as long as like the client is asking for several information, buying several different items in that particular shopping cart application, okay, by visiting through several web pages, so all the information is actually saved in that particular state for that particular client. Okay, so that is the session state data in that particular information. You can basically save this session data using local variables. A simple variable you can maintain, and then like or say for example in complex applications, like you may need some very complex things. Okay, say for example you may need to have a data structure which actually stores the client ID and also like all the shopping cart information. Okay, for most of the basic applications, like using a local variable is already sufficient. Okay, and whenever we will be trying in terms of the threads is concerned, like having a local variable is already sufficient for us for the simple network based applications and services which are being provided. For complex network applications like the shopping cart, I already discussed, like we may have to use our own data structures for that one. So let us try to think in terms of the global state information. Okay, so to give you an example, okay, to give you some feel of the source code, how the state information is actually maintained, either for per session or for the global state, so which is actually maintained for all the clients. Okay, so let me try to give you an example for this. Okay, So the global state information actually is maintained by the server for all the clients. Okay, think about a counter protocol. There is nothing like a counter protocol, standard protocol, but assume like there is a server and then there are several clients are trying to communicate. So each time like a client is trying to talk to the server, okay, the server will basically increment some counter and then like it will be basically giving it particular number. Say for example, the first client will get count as 1, then the second one, so it will basically get a response like 2. So how many number of clients have actually contacted the server by the time? So that is the number which will be returned for it. So let us think about a counter protocol, something like that. That is what I will try to demonstrate to you. So here like you just need to use a primitive data type is sufficient for you. But of course like since you want to have that variable accessed by all the different threads, better that save it in a static variable. Okay, I will show you in the example. And when you are updating, you should be basically worried about synchronizing it so that like you achieve this mutual exclusion. So when we were discussing the threads, like I already talked about having this sort of synchronized keyword, okay, that method or like that block of the code will be basically synchronized so that like you achieve mutual exclusion. Okay, that's about like simple primitive types. Of course, like more complex types, as I already talked about, like you can have a file or a database or a data structure, whatever it is. But this global state information is actually maintained throughout the lifetime of a server. So let me try to demonstrate that one to you. As I said, like I had another simple client and another server, which is counter server. Okay. This time, like what the server is doing is like, of course, this time I'm using the datagram sockets again. Okay. We have actually seen all the base code earlier in the examples, so you will be able to understand. So anyhow, I'm going to give all the code snippets for you. Okay. The client is the one like which is actually trying to start communicating with the server. Okay, datagram socket existing on the server, which is here in this case by default like localhost and then like on a port number 12345. Okay, and then like you are trying to send some message, whatever may be the message, doesn't matter for you. Okay, and then like all you are trying to get is like get the count. Okay, so in fact actually what you are doing in the helper class is like you are again like creating this sort of my client datagram socket. Okay, and then like you are sending some message. Okay, and then like you are basically receiving that particular message. And here in this case like you are sending the message which is actually empty, which we have seen with daytime server. Okay, when we were using with datagram sockets. Okay, and you will send the request, and that means like you are sending the datagram packet. The datagram packet is actually used by the server to basically be able to send the response back. The response it is actually sending is like just message received. Okay, and then like it is actually sending what is the number. Okay, so what is the client number, current client who is trying to contact. That's all. So from the server side, all it is doing is like it received the message and then like just it is incrementing this counter. The counter is the one which is actually the static variable which is actually maintained by the server. This is the stateful information for you in this case. So the counter is the one which is actually telling how many clients have come to that particular server until that particular time. And you have this counter, okay, which is static. So if you basically increment it, okay, say for example, if the server is threaded, okay, you have multiple threads, even then like the increment should be properly incremented. That is why like you need to have this synchronized. So right now like this server is not a threaded server, okay, but then like you can actually make it a threaded server even though it is based on datagram sockets. This you have tried as part of exercise 4. Okay, so when you have such a thing like basically like the increment of that particular variable, that particular counter in this case shouldn't happen in a synchronized method. So once you have this one ready, okay, so all other boilerplate code, so we have already discussed, so I just don't have to talk about those things. So you have the my datagram sockets server side and also like my client datagram socket as well, and we have this sort of datagram message as well. Okay, let me try to run it first. Okay, then you will actually understand what it is actually doing. So the counter server is ready. Let me try to send a client. Okay, run. So the client 1 is ready where it is trying to connect. So local host, it is trying to connect. The port number is 12345. Default is also like it will take 12345. So this is the first client. So the client got terminated. Okay, but the server is still maintaining that variable. One client has already come. So let us see, like say for example, let us start another client. Okay, this time, okay, so that means like localhost if I don't put any information, the same port. So this is the second client. So the server is actually maintaining that information. That is the state information it is actually maintaining. And in this case, like it is not per session, so it is not state session data, okay, but rather it is the global state information. So every client like is trying to come and talk, it is actually incrementing that global variable for you. Similarly, like for per session, like you can actually do that one, okay, and you can actually adapt the relevant source code for that one. So let's get back to the slides. So here we have seen like how the state information is actually maintained. So and this global state information is actually maintained throughout the lifetime of the server. In actual implementation, a server can be stateless, or it can be stateful, or it can even be hybrid. Some of the state information is actually saved with the client, and other information may be saved at the server side as well. So even hybrid type of server is also possible. Which type of the server is actually chosen is a design issue. Okay, based on the requirements of your application during the design stage, you will decide whether your server will be a stateful or a stateless server. So regarding the reference are concerned, with this one, like we have finished chapter 5 of distributed computing principles and application by ML. Thank you very much for your attention.